Something unbelievable just happened on Mars. Something so tiny that no camera could capture it. For the first time ever, NASA has confirmed real electrical sparks crackling inside Martian dust clouds, detected directly by the Perseverance rover's ultra-sensitive microphone. These microscopic flashes could rewrite what we know about Mars' atmosphere, its chemistry, and even the search for ancient life. How can something so small change so much? Let's uncover the full story. The hidden sparks. Here's the strange part. These sparks aren't lightning as we know it. There's something entirely different. Instead of bright lightning bolts like we see on Earth, scientists found short, sharp electrical discharges hidden inside Martian dust clouds. Tiny crackles that Perseverance somehow managed to hear. Over 2 Martian years, the rover recorded nearly 29 hours of atmospheric audio. Hidden in that audio were 55 distinct electrical crackles, each appearing during active dust movement. These signals weren't random noise. They perfectly matched what happens when tiny dust grains collide, steal electrons from one another, and suddenly release that charge as a spark. And it all happens in an atmosphere almost nothing like Earth's. Mars has a thin CO2 atmosphere, only about 0.6% as dense as ours. In such low pressure, it takes far less energy for an electrical breakdown to happen. So even gentle dust activity can trigger electrical discharges. These sparks appear during dust devils, swirling dust storms, and every moment when airborne grains rub together at high speed. It's like rubbing a balloon on your hair, except you scale that up to millions of charged particles spiraling through a Martian storm. For decades, scientists suspected Mars might have electrical activity, but they never had proof. Orbiters saw huge dust storms. Landers felt the winds, but no mission until Perseverance had the tools to literally listen for static electricity. Now we finally have confirmation, and it changes everything. These tiny sparks validate decades of predictions about dust electrification. They also give us brand new tools to understand how Mars forms storms, how dust gets lifted off the ground, and how the atmosphere behaves on a planet with almost no air. But that brings us to a much bigger question. If Mars has electrically active dust storms, what does that mean for its chemistry? And what does it mean for the search for ancient life? Chemistry and clues. These sparks aren't just a cool discovery. They directly shape the chemistry of the Martian atmosphere. When dust grains collide, build up charge, and suddenly discharge it, that electrical energy triggers high-energy reactions in the surrounding CO2-rich air. One of the biggest products scientists believe is created through this process is hydrogen peroxide, a reactive oxidant that previous missions detected but could never fully explain. Now, the missing piece has finally clicked into place. Hydrogen peroxide isn't just a harmless molecule. It destroys organic compounds, the exact fragile molecules that missions like Perseverance are hoping to find as clues to ancient life. So if sparks are constantly generating oxidants, then Mars' surface may be far harsher to organics than we hoped. It means ancient biological signatures could be degraded faster than expected, or even erased from exposed surface layers. But the story doesn't end there. Electrical energy can also do the opposite. Under the right conditions, it can create complex molecules. On early Earth, lightning was one of the forces that helped generate prebiotic chemistry, the first chemical building blocks of life. So even on Mars, tiny sparks may be shaping chemistry in ways we never imagined. They could be forming new compounds, changing the balance of gases, or influencing long-term atmospheric evolution. To understand it all, scientists now need answers. Where do these sparks happen most? How often do they occur? Are there chemical hotspots where oxidants build up? These answers directly affect future missions, especially sample return. If certain regions are chemically harsh, those might not be the best places to collect rocks that preserve organics. This discovery forces us to rethink atmospheric models entirely. Mars is no longer just a cold, passive desert. It's a reactive world with storms electrified by bursts of crackling energy. And that brings us to the next big challenge. What does this mean for future explorers, both robotic and human? Future missions impact. Here's where things get serious. Electrical dust storms aren't just a scientific curiosity. They're an engineering challenge. When dust grains charge up, they can influence how materials degrade, how sensors respond, and even how communication systems behave. For future rovers, and eventually human habitats, charge buildup could pose risks, especially in massive regional storms where dust density skyrockets. Understanding the frequency of sparks helps engineers design safer systems with better grounding, improved insulation, and dust-resistant surfaces. But there's a huge scientific advantage too. Electrical activity acts like a diagnostic tool. Sparks reveal the structure of dust storms, the density of airborne particles, and the level of atmospheric instability. If future missions include upgraded microphones or electromagnetic sensors, they could map storms from the inside, using electricity as a guide. This is essential for safe landing windows, navigation, and long-term human missions. Scientifically, Mars now joins a group of planets where atmospheric electricity affects weather: Earth, Jupiter, and Saturn. But Mars is unique because its atmosphere is so thin. It gives scientists a rare laboratory, a natural experiment in low-pressure electrical physics. For human missions, the implications are major. If dust sparks constantly produce oxidants, astronauts will need protective materials for suits, habitats, and sample containers. Handling Martian soil might require new protocols to prevent chemically reactive exposure. Future missions may even include dedicated instruments specifically designed to measure static buildup and micro-discharges. Perseverance detected these sparks almost accidentally. Imagine what a rover designed intentionally for this could reveal. All of this leads to the final, bigger idea. What does this discovery reveal about Mars as a world? With just a few seconds of faint crackling recorded by Perseverance, Mars has revealed a new identity, a world far more dynamic, reactive, and electrically alive than we ever imagined. These tiny sparks reshape how we think about its storms, its chemistry, and our chances of finding preserved organic clues. Every future mission, from sample return to human exploration, will rely on what we've learned from this discovery. Mars still has countless secrets hidden in its dust, and now we know the dust is sparking with electricity. Thanks for watching, and don't forget to like, share, and subscribe for more deep space discoveries. Your support means the world and keeps our journey going.